This week we will be talking about volume. Volume is the amount of space inside a container. So it's usually how many cubes will fit inside a particular container. This is for 3D shapes, which are either prisms or pyramids. We're going to label each of these shapes and write the formula. So this first one here has two bases. And the shape of that base is a rectangle. And prisms and pyramids are both named for the shape of their base. If it has two bases, like this, then it is a prism. And according to our formula sheet, the formula for a rectangular prism is volume equals area of the base times the height. The next one only has one base, and the shape of that base is a rectangle. So it's a rectangular pyramid because it only has one base. And according to our formula sheet, that is volume equals 1/3 times area of the base times the height. The next one also has two bases, and the bases are parallel to each other. So I can see there's a top base that's a triangle and a bottom base that's a triangle. So this is a triangular, and since there's two of them, it's a prism. And again, the formula for a prism is volume equals area of the base times the height. This next one, there's two parallel sides, and they are both shaped like a triangle. So this is a triangular. And since there's two, it's a prism. So it is exactly like the other one. It looks a little different, but it's the same shape. It's a triangular prism. So the formula is still volume equals area of the base times the height. The next one has lots of parallel sides actually, but they're definitely shaped like squares. You could call this a cube, but it is also a rectangular prism. And the formula for a rectangular prism is still volume equals area of the base times the height. And this last one only has one base, and it is shaped like a triangle. So it is a triangular pyramid. And the formula for a triangular pyramid is volume equals 1/3 area of the base times the height. Now let's list some real life examples of these, because when you're looking at them in STAR problems, they talk about real life shapes. So look around the classroom and see if you can find a rectangular prism. If you're in the classroom, you might have noticed a whiteboard eraser, or maybe a tissue box. You also might think of a pizza box. A typical square pizza box is a rectangular prism. A Rubik's Cube might be a rectangular prism. What about triangular prism? That might be the sliced pizza box that we looked at. Or maybe a tent. An empty binder is shaped like a triangular prism. Or a slice of cake, that would be a triangular prism. What about a square pyramid? Sometimes pencil toppers, those erasers, those are shaped like square pyramids. They even have Rubik's Cubes that are shaped like square pyramids. A radio tower, that might be shaped like a square pyramid. Or sometimes a decorative fence post. What about a triangular pyramid? Maybe a caution sign, caution, wet floor. You know, those little tents that they pop up in the hallway to let you know that the floor is wet. Let's look at the meaning of those letters that are in the formula. V means volume. That's what it stands for. And every time you see the letter V, you need to say the word volume. So volume, which is how many cubes will fit inside. B means area of the base. So unless the word problem just specifically tells you the number for the area of the base, for the capital letter B, you're going to have to plug in a different formula. So unless the problem tells you the number for the area of the base, you must plug in a formula for area of the base. H means height, height of the pyramid or prism. So the height goes from one base to the other, or it goes from the base to the point of the pyramid. Let's look at a couple of examples of the shapes and see if we can find the base and the height. So this first one, remember the bases are parallel to each other. So the base are these two triangles. And the height is the distance between those two bases. So that would be right there. On this one, the base, usually they tell you on these, since all the sides are parallel to each other, they usually tell you where the bases are. We're going to label the base as the top and the bottom. Then the height would be the distance between them. The base on the pyramid is the bottom. And the height is going to be the distance from that point right through the middle of the pyramid to the bottom. Goes straight through the middle. That's the height. Let's look back up here at the top. We have this little picture. Our formula is volume equals area of the base times the height. And this picture kind of shows why that formula works. This one right here demonstrates the base. So the area of the base be base times height. So we could count 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4. So 6 times 4 would mean that this layer right here is 24 square units. Well, then that means this layer is 24 square units. This layer is 24 square units, and this layer is 20. Each layer is 24 square units. And it's 8 units tall. So if I multiply the area of the base times the height, then I'll know the volume of the entire container. Okay, let's look at some examples together. Number 1, the dimensions of a rectangular pyramid are shown. What is the volume in cubic centimeters? Well, first of all, this is a rectangular pyramid, and the volume formula would be 1/3 area of the base times the height. So for that capital letter B, I need to plug in a different formula. The shape of this base is a rectangle, so I plug in the formula for a rectangle, base times height. I also still need to multiply times 1/3 and times the height of the pyramid. So that's my map. Now I can plug in the numbers. 1/3 times 10 times 8, those are the numbers on the base, times the height of the pyramid. Okay, before I start multiplying, I want to try to simplify if possible. Is there some number that I could find 1/3 of? Or 3 will go into 12 4 times. Now I just need to multiply 10 times 8 times 4, which is 320. Number 2, a container in the shape of a triangular prism is used to hold a flag. The dimensions of the container are shown in the diagram. What is the volume of the container in cubic inches? This is a triangular prism. So the formula for a prism is area of the base times the height. And the shape of a triangular prism is a triangle. Therefore, where the capital letter B is, I need to plug in the formula for a triangle. And then I'm still going to multiply times the height of the prism. So there's my map. 1/2, and then I want the base of the triangle, which is 25, times the height of the triangle, times the height of the prism. So that's from one base to the other base. That's this distance right here, the 3.5. And again, you want to find half of a number or find something that 2 could simplify with. And 2 can simplify with 12.4. It would become 6.2. And then you multiply those. 25 times 6.2 times 3.5. Number 3, a caution sign in the shape of a triangular pyramid has a height of 28 inches. The area of the base of the sign is 100 square inches. What is the volume of the speaker in cubic inches? Well, I think that's supposed to be sine. This asks for the volume of a triangular pyramid. The formula for a pyramid is 1/3 area of the base times the height. And it tells us the height is 28 inches, and the base is a triangle, but it tells us the area of the base is 180. So I don't need a formula. I can just plug in the number 180 where the B is, and then times 1/3 and times the height, which is 28. Try to simplify. I can divide 180 by 3. That would be 60. And 28 times 60 . Number 4, a treasure chest is composed of a rectangular prism under a half cylinder. The rectangular prism is completely filled with treasure. The dimensions of the rectangular prism are shown in the diagram. What is the volume of the rectangular prism in cubic inches? Rectangular prism, so that's area of the base times the height. And this base is shaped like a rectangle, so I need to plug in the formula for a rectangle and still multiply times the height of the prism. So there's my map. Now I can plug in the numbers. The measurements for the base are 11 and 18, and the height of the prism is 13. Number 5, the dimensions of a triangular prism are shown in the diagram. What is the volume of the triangular prism in cubic centimeters? Well, the formula for a triangular prism is area of the base times the height. And since it's a triangle, we need to plug in the formula for a triangle. 1/2 times base times height times the height of the prism. There's my map. Then I need to plug in the numbers. 1/2 times the measurements on the base. The base is the triangle, so 6, and this is pointing to the height. Remember, the height is at a right angle. And then the height of the prism is 16. We did not need this measurement. Okay, first look for a number that we could simplify. Half of maybe 6 is 3. 3 times 4 is 12. Then multiply times 16. Number 6, 2 congruent squares and a parallelogram were used to form the figure below. What is the area of the figure in square meters? So this is just squares, that's surface area. So we only need to find the area of this shape. It says there are 2 squares, and it looks like they have the same measurement. So 2 times the formula is base times height plus this parallelogram, which the formula for a parallelogram is also base times height. Then we can plug in our numbers. 2, and the measurement on the square is 3, and the other measurement, well, it's a square, so all the sides are going to be 3, plus the base of the parallelogram is 6, And the height, remember the height has to be at that right angle, 2.8. Well, 2 times 3 is 6, 6 times 3 is 18. 6 times 2.8 is 16.8. Then you add those together. Remember when you add those together that you need to line up the decimals. Number 7. The diameter of circle J is 12 centimeters. The diameter of circle C is 10 centimeters. Which measurement is closest to the difference between the circumference of circle J and the circumference of circle C? Difference means we're going to subtract. So we're going to subtract the two circumferences. The formula for circumference is pi times diameter. So we're going to put the big circle minus the little circle, and the formula will be the same for both. The number we use for pi is 3.14 times the larger diameter was 12 minus, still the number we use for pi is 3.14 times the smaller diameter, which is 10. .14 times 12 is 37.68 minus 3.14 times 10, just have to move the decimal over, so that would be 31.4. And when you subtract, you have to remember to line up the decimal.